Have you ever wondered what lies beyond our Earth? What type of wild and exotic planets make up the rest of our solar system? Our universe is full of wonders, with each planet offering a unique adventure waiting to be explored. In this video, we're going to take you on a journey to uncover the secrets of our solar neighbors. Make sure to watch till the end, when we will share an amazing fact about one of our most distant planets. So buckle up and get ready for a look inside our solar neighbors. Let's begin. The solar system we call home is a fascinating place. With 8 planets, along with asteroids, comets, and meteoroids, it's a cosmic wonderland. It is believed to have formed 4.6 billion years ago and is located in the Milky Way galaxy. Each planet in our system offers unique features, from scorching temperatures of Venus to the icy rings of Saturn, and each one has something special to offer. Let's take a closer look at what makes each of our solar neighbors unique. The Sun is the heart of our solar system, and it's a brightly burning nuclear furnace. It emits more energy in 1 second than what humans have used since prehistoric times, making it an essential source of life on Earth. The inside structure of the Sun consists of several layers. The core at its center contains 2/3 of its mass and is the hottest part, with temperatures reaching over 27 million degrees Fahrenheit. Surrounding that is a thick layer known as the radiative zone, which slowly cools down from 7 to 2 million degrees Fahrenheit. This area plays an important role in solar energy transfer before finally cooling down enough for convection to take place in the outermost layer called the photosphere. This layer creates sunlight as plasma particles jump from the radiative zone to this photosphere, where they cool and escape the Sun's magnetic field. This process is what helps make up the Sun's immense energy and drives life on our planet. Mercury is the closest planet to our Sun and one of our smallest planets. Its rocky, heavily cratered surface tells a story of billions of years of meteor strikes. On its day side, temperatures reach up to 800 degrees Fahrenheit, while on its night side, they plunge as low as minus 290 degrees Fahrenheit. Despite this extreme temperature range, there are still traces of ice found in some craters at the poles. Inside Mercury is an iron-rich core that makes up about 60% of its mass, surrounded by a mantle composed primarily of silicate material. This core gives Mercury its magnetic field, which helps protect it from the Sun's solar winds and radiation. All in all, Mercury is a fascinating study in contrast due to its vast temperature differences and unique internal structure. Venus is the brightest planet in the sky, and it's known for its striking yellowish-white color. It has a thick cloud cover that consists mostly of sulfuric acid, making it one of the most inhospitable places in the solar system. The temperatures on Venus can reach up to 880 degrees Fahrenheit, hotter than an oven. Its internal structure is believed to be composed of a core similar to Earth's, made up of iron and other elements. Above this core lies a mantle that is thought to contain some iron too, but with sulfur replacing oxygen as one of the main components. The mantle also contains molten rocks, which are heated by radioactive elements at its center. Finally, there's an atmosphere made up of carbon dioxide and sulfuric acid, composed of layers of grey clouds. Its surface is scarred with craters and volcanoes. This makes Venus one of the most extreme places in our solar system. Earth is our home planet, and it has many features that make it special. Its atmosphere is composed mostly of nitrogen and oxygen, which help protect us from harmful radiation and keep the entire planet in a habitable temperature range. The magnetic field around Earth acts as a shield, deflecting dangerous particles from space away from us. Additionally, Earth has liquid water on its surface, something unique among the planets in our solar system. This liquid water is essential for life as we know it. At its core lies a solid inner core made mostly of iron and nickel, surrounded by an outer core composed of molten iron and nickel. Both are extremely hot due to the energy of geologic activity within the Earth. Above these layers lies the mantle, a thick layer composed of molten rock that is constantly in motion due to convection. Sitting atop the mantle are multiple layers of Earth's crust, its outermost layer, which holds our oceans and continents. All of these layers together make up the structure of our home planet. Mars is the red planet, known for its distinctive hue due to iron oxide dust suspended in the atmosphere. This thin atmosphere contains carbon dioxide and nitrogen, with traces of other gases such as argon and oxygen. It is believed that Mars was once much wetter than it is today and had rivers flowing across its surface. The internal structure of Mars is similar to Earth's, a hot, dense core made up of nickel, iron, sulfur, and carbon dioxide, surrounded by a mantle of silicate rock that extends up to 2,180 miles in thickness. Above this layer lies an outer crust, composed mostly of basalt rocks, which are heavily impacted by meteors. The most notable feature on Mars's surface is Olympus Mons, the largest volcano in our solar system. It is believed that Mars's core has cooled down, preventing any further volcanic activity. Mars remains one of the most intriguing planets in our solar system and may potentially harbor signs of past life or even be able to support life again in the future. Further explorations of this red planet will no doubt reveal more fascinating facts about its origins and internal structure. Jupiter is the largest and most massive of the 4 gas giants in our solar system. It's made up mostly of hydrogen and helium gases, with its upper atmosphere containing traces of water vapor, ammonia, methane, and sulfur. The core is thought to be composed mainly of rock and ice. Jupiter has some of the strongest winds in the solar system, reaching speeds between 360 and 430 miles per hour, or 582 to 692 kilometers per hour. These winds are driven by intense heat created from within the planet itself due to powerful storm systems that can last for centuries. Scientists believe that these storms are a result of convection currents caused by differences in temperature inside Jupiter's atmosphere. Internally, Jupiter is believed to have a rocky core surrounded by layers of liquid metallic hydrogen, liquid helium, and an atmosphere of hydrogen and helium gas. Its core is thought to be about the same size as Earth's. However, the high pressure inside Jupiter prevents us from seeing it directly. Jupiter is a truly fascinating planet to study and explore. With its vast size and ever-changing storms, we can learn a lot about our solar system by studying this giant among planets. Saturn is the second largest planet in our solar system, and its atmosphere is composed of mostly hydrogen and helium gas. At its core lies a rocky material surrounded by liquid metallic hydrogen, which increases in pressure as it gets closer to the center of the planet. This hot liquid metallic hydrogen makes up most of Saturn's mass, 95 times more than Earth's. It's also the least dense planet among all those in our solar system, with only 1/8 of Earth's average density. Its unique internal structure gives Saturn a faint orange hue due to traces of sulfur in its atmosphere. And don't forget about those iconic rings around it. Thanks to its beauty and fascinating features, Saturn has always been an object of intrigue for astronomers and the public alike. We certainly have much to learn about this majestic planet. Uranus is the 7th planet from the Sun and one of 2 ice giants in our solar system. It is a blue-green gaseous world with an atmosphere primarily composed of hydrogen and helium, but also has some methane gas, which gives it its distinctive color. This gas giant's internal structure consists of a solid rocky core at its center, surrounded by a superheated mantle made up of water, ammonia, ice, and methane. This mantle makes up 80% of Uranus's mass and reaches temperatures as high as 9,000 degrees Fahrenheit, much higher than Jupiter's mantle. The core itself contains about half the mass of Earth and is theorized to contain iron or silicate rock. Its atmosphere extends down about 20% into the mantle. Uranus is the least dense of all planets in our solar system, and its mass is 95 times that of Earth. With its unique internal structure, Uranus stands as one of our most fascinating neighbors in the solar system. Neptune is the windiest place in our solar system, with clouds of frozen methane whipped across its face at speeds of up to 1,200 miles per hour. Its inner core is solid and mostly made up of iron, plus a possible layer of diamond crystals. At a depth of 4,500 miles, Neptune's internal structure also consists of a large mantle containing methane, ammonia, and water, as well as an atmosphere that forms 5 to 10% of its mass. The atmosphere is made up mostly of hydrogen, 80%, and helium, 19%, with traces of methane gas responsible for the bluish hue. As you move deeper into Neptune, temperatures reach 9,000 degrees Fahrenheit. It's truly an incredible planet worth exploring further. Pluto is the last stop on our journey around the solar system and is the smallest and most distant of the planets. Scientists are still debating its size due to its distance from Earth, though it appears to be bigger than other dwarf planets in the Kuiper Belt. Its composition is mainly rock and ice, with temperatures as low as -400 degrees Fahrenheit. or minus 240 degrees Celsius. The internal structure of Pluto consists of a rocky core surrounded by a mantle, made up of water, ice, and frozen methane. This icy crust is heavily cratered and contains nitrogen, carbon monoxide, and methane ice, giving Pluto its striking yellowish-brown hue. The atmosphere surrounding Pluto consists of nitrogen and traces of methane gas, which slowly escapes into space, being released from sublimating ices and molecules in the atmosphere. This is why Pluto cannot maintain an atmosphere like other planets, and has a temperature so low. To sum up, our solar system is an incredibly diverse and interesting place to explore. Each of the planets has its own unique features that makes them fascinating for astronomers and laypeople alike. From the gas giants Jupiter and Saturn to ice giants Uranus and Neptune to distinct Pluto, each planet has something special that makes it worth exploring further. With ongoing research and exploration, who knows what else we may discover about these amazing neighbors of ours.